Hello, everyone, and welcome to today's session. My name is Doug Olenek, and I am the online editor for SC Media and the moderator for this program, which is sponsored by ThreatX. Our topic is Strengthen Your Web App Defenses Using Behavioral Analysis and Attacker Deception. Joining us today is Kelly Brazil, Vice President of Sales Engineering at ThreatX. Now, before we get started, I'd like to mention one quick housekeeping item. There will be a question and answer period after the presentation, so please place your questions in the space provided on your screen. Okay, now, overburdened security teams are finding it increasingly difficult to keep pace with the volume and sophistication of daily threats. This, coupled with the limitations of traditional WAF signature approaches, has left many organizations desperate to find a solution. What we need are faster automated detection and remediation options, but the path to a solution may not be all that clear. So today, Kelly is going to try and make that path as clear as he can. And with that, I'd like to turn the show over to Kelly.
All right, thank you, Doug. Appreciate that, and appreciate the time here to kind of discuss this new way of tackling web application security. So on the agenda today, we're going to talk about why the need for new detection and prevention strategies, and then we're going to go into the different types of behavior analysis that can be used in application security above and beyond the signature-based approaches that we've been used to. And then we're going to talk about the strengths and weaknesses of the behavior analysis approaches, and then do an overview of techniques for not only the behavior analysis, but also attacker engagement and deception and how they all work together. And so let's, without further ado, let's just kind of jump into that. So the first thing that we're going to talk about is, why detection and prevention models must evolve. And so we kind of understand the history of the web application firewall industry about 15, 20 years ago. Started as a signature-based approach, and this is basically the same across the board for all security analytics since the early days of antivirus. Everything seemed to start with a signature-based approach, and then over time we found that signature-based approaches have their benefits, but they also have big downsides, and that comes down to a huge operational burden when it comes to tuning signatures. And whenever there's new threats that come out or threat vectors, the signatures have to be retuned to basically catch those new threat vectors. So there's sort of this cat and mouse game that is constantly going on. And what that means for organizations is that there's this burden that requires headcount to just basically kind of babysit and tune these signatures. So, like I said, we've seen the whole industry move more towards a behavioral-based approach, whether that's the endpoint EDR type of solutions, all the way to network security. And so, what we're talking about is using the same techniques for web application security. And the idea is that instead of having the status quo today, where really only 10 to 15% of applications are being covered by a web application firewall. Even for organizations that do deploy web application firewalls, we want to get that to 100%. And not just the traditional web applications, but also, APIs and microservices are also considered web applications too today. And they have their own challenges, right? They change much faster than traditional web applications. So there's so many reasons why the traditional approach just isn't working. And there are other problems with signatures. You almost have this paradox. When you write a signature, you have the choice whether to make it very generic or very precise. And each one has their pros and cons. And so we've kind of seen this over the past couple decades of signature-based approaches where you could have very highly specific signatures but that are very geared towards known attacks. But the problem is that we tend to make them so specific that it's easy to evade those signatures whenever there's a slight change in the attack vector, which means that you're not covered for unknown attacks. And so you get a lot of false negatives, and you have to have a lot more signatures. So it's not uncommon for a WAF to have hundreds of thousands, even millions of signatures. And as you can imagine, that's just a huge burden on the security analytics team. And then on the other side of the coin, you have more generic type of signatures, and the idea is that then you can kind of cover unknown threats, and as the attack vectors change, you don't necessarily have to write a new signature. But the problem is that you get a lot of false positives because you start mistaking normal user activity for threat activity. And so that's always been the challenge, to kind of thread the needle between these two approaches here. And there's no perfect way to write a signature. It's kind of both an art and a science. So we kind of need a new approach, and that's sort of where the behavior-based approaches has come from. Now, I'm not here to say that all signatures are bad. There are good uses for signatures. One of the nice things about a signature is it's very deterministic. You get decisive results. It's very binary. When a signature fires, it's black and white. This was a deterministic hit, and you can basically say, okay, this is good or bad, depending on how well your signature is written. And that lends itself to really nice automation. So you can basically feed those hits into some type of a SIM or some other type of aggregation, so you can make higher level decisions on that. But unfortunately, again, this is based on how well the signature is written. So that requires, again, like we talked about, that constant tuning and balancing those false positives versus the false negatives. And we also see that signatures are very myopic. Typically, when you're writing a signature, you're looking at a single web request and whatever tuple information is inside of that web request, whether it's the headers and the source IP and things like that. And so you're not really keeping a lot of state. So you can miss a lot of the layer 7 slow and low attacks that might happen over a longer period of time. You might miss out on automation, where you see a particular threat actor that's doing things across many sessions or even across many different IP addresses. And you sort of miss the big picture of the attack progression, where we've all kind of been trained to look for different type of attack frameworks, whether it's MITRE or the Lockheed Martin kill chain. As a particular signature has its role within that, but the signature itself isn't going to be able to see the attack progression. So the goal of the next-gen AppSec is to basically provide that decisive and automated protection to all threats without having to do manual tuning and manual building of rules to basically pull together all these different signatures. So let's talk about behavior analysis and how it relates to application security. First of all, why use behavior analysis? Well, the idea is to focus on actions and not appearances. So a signature is basically looking for like a telltale appearance of a threat activity. But what we really want to do is look for the actions or the tactics and procedures that attackers use to basically break into applications. And a lot of that has to do with the obfuscation techniques that they use and the fundamental characteristics of a threat, whether it's a known reconnaissance tactic or even something as specific as a SQL injection. So we want to basically take a step back and look at what are the different kill chain stages that an attacker goes through when they are actually trying to break into a web application. Behavior analysis gives us high dimensionality. So it means that instead of just that single tuple that we're looking for in a signature, where it might be the source IP and headers and maybe some regular expressions within the body, we can actually take a step back and train machine learning models to look at a variety of traits and basically look at those over time as well. So there's a lot broader context that can be introduced into a behavioral analysis engine. And that enables us to focus on the big picture and look for commonalities within different threats instead of just creating a new signature for every CVE that comes out. So what this allows you to do is see not only known threats but also unknown threats. So it gets you closer to catching that zero-day threat. So there's a couple of types of behavior analysis. We'll talk about both application profiling and attacker-centric profiling. So they both have their use cases, and they actually really work well together. And we'll talk about how that works. So the first thing you want to do, especially for a web application firewall, is you want to profile the application. And so what that means to profile is to learn the normal patterns of the application's behavior. So as users are using the application, what are the normal response times of, say the front end and maybe the back end database responses? What's the typical intensity of how users engage with a particular part of the web application? And how many connection flows are normal? And so we can do this with what we call unsupervised machine learning. And so that means that the algorithm learns these patterns without any input from the humans. So it can basically do cluster analysis and things like that just by looking to see what is normal versus abnormal. What are anomalies? So this really helps to reveal signs of automation, reconnaissance, enumeration, attack progression. So again, these are more just providing anomalies that aren't necessarily threats, but they are something that is out of the bounds of normal and might require more investigation. Now, if we were to stop there, that might be an improvement in some sense over a signature-based approach in that it would kind of uncover some unknown threats. But it would also have the disadvantage of increasing the burden on the security team, because now you would have these anomalies that need to be investigated. And as everyone knows, anomalies could be real threats, or you could just be chasing a ghost. And that could be a couple hours of investigation and correlation on your SIM just to figure out that, at the end of the day, it was just a false positive. So we have to do more than just the application profiling. So the next one here is the attacker-centric profiling. So let's take the output of that application profiling and input that into the attacker-centric models in addition to the actual attacker behaviors. And so this will help us to learn what the attackers are doing and what types of threats, of actual threats that are being actioned against the web application. So we refer to this as supervised machine learning because we're training an algorithm with a large number of known good and bad samples. So this is where we actually input the known tactics and procedures of the bad actors. And so, basically, these are tagged samples, and so we can say, hey, these are good ones, these are bad ones. Marry that with the application profiling data as well, and come up with a very accurate rendering of what is bad traffic. So this is really strong at revealing, what attack platforms might be hitting the site. Specific malware behavior, so is this, say, MJ12 versus Yisu Spider or some others, known exploits like maybe Apache Struts or whatever. So this is actually taking it to the next level so that you can not only see that an anomaly happened, but you can actually see that specific threat activities happening and that there's kill chain escalation going on over time. So this is good for not only the quick kind of script kiddie things that happen, but also for the low and slow persistent attacks that can happen over longer periods of time. Okay, so we talked a little bit about behavior analysis and a couple of different techniques and how those can work together. But there's also another piece that can also work alongside behavior analysis to really increase the efficacy of detection and the accuracy, and that's the attacker engagement and deception. So what's kind of nice is that you can actually engage attackers in real time. As an analyst, if you get a log message that comes in and says that something suspicious is happening, you don't have that opportunity because the attack has already happened. But if you are doing this in a real-time approach, you can actually engage the attacker in real time to get more information. So, for example, you might want to confirm the identity of the end user. So, an example of this might be, is this a Phantom.js headless browser, or is this a real Chrome browser, or is this a curl script that's hitting me, right? None of those, really indicates a threat necessarily, but they do give you more information to understand whether this is automated or potentially automated or a real human being behind the screen. And you can feed that information into your risk models. You can track behavior over time. So something that we call fingerprinting, where you can send down cookies in JavaScript and basically kind of follow an attacker around as they hop around IP addresses over time, and then correlate all those behaviors to a single entity, even though that entity might be hopping around IP addresses. So that's really important, because that's a common thing that attackers do, right? They will do some of their attacks with a single IP and then move on to another IP to try to evade a WAF. And this is a slow and low type of attack as well, because this could happen over the course of days or weeks, not just all within a 1 hour time period. And this can also help to determine the attacker's motives. So when we use deception, for example, maybe you want to send down fake form fields or parameters and things like that. A normal human being that's using the application isn't going to be concerned about that. It's not going to see those fields, and they're not going to click on them. But if we start to see them being clicked on, then we can kind of infer that maybe this is a crawler, or maybe this is some type of automated bot. And then that again can be we can basically cycle that information back into the risk modeling. And the idea is just to make this more and more accurate, give you more and more context beyond just the signatures to make an accurate block or allow decision. Some types of deception, like we talked about this a little bit, but you could use things like hidden fields. I'm not going to get into much detail here, because obviously we don't want to give away trade secrets, but these are some common things that might be done. You might send some hidden fields that you wouldn't necessarily see in your browser, but if there's a web crawler, they might see these fields and see what they do. And as soon as they trip on those, then you can basically feed that information back into the risk modeling. You can also do attacker manipulation. So you might want to slow down their responses to the attacker. Maybe they're doing some type of layer 7 attack, and they're doing these long-running queries on the back end. So you might want to slow those down, because those are expensive. But this could also be a type of deception, because a lot of times advanced attackers will do what's called blind SQL injection. And so they're not looking for any textual output to come back to them. What they're really trying to do is determine what type of database they're dealing with on the back end. But if you can manipulate the timings of those responses, then that makes it harder for them to understand whether their blind SQL injection attack was actually was successful. And so it just makes them be more and more obvious in the type of attacks they have to do. It confuses them. So all these work together to kind of give us a better model of what this particular entity is doing. So we talked about a few different techniques, but now let's talk about combining all these models together to make better decisions. And so what we mean by that is that as a human being, what you typically do is, when you're investigating something manually, you're going to take a bunch of different signals, and you're going to, use your intuition and your training and kind of put 2 and 2 together and see whether something makes sense or not. Traditional signatures don't have that level of intelligence. They're just going to tell you whether something fired or not based on a match. So what we mean is taking all of these approaches of the attacker behavior, where we're looking for fundamental tactics and procedures of the attack, the application behavior, where we're looking for anomalies and how the application is being used, and then also the active engagement, where we can challenge the user, get more intel about them. And we're in that sweet spot there where we have all 3 of those things working together. It means that we can get a lot more fidelity and higher accuracy than just signatures on their own. And the nice thing is that we can do this without increasing false positives. In fact, by doing this, you actually reduce false positives, because now you're making intelligent decisions based on more context than just a static signature. So what you do then is you pull all of those different inputs into something that a human being can understand, like a risk score. So we understand things like your credit score has a number. So you could basically aggregate all this information coming from these different inputs into a single risk score, let's say 1 to 100, and you can weight these different inputs for higher accuracy. And by doing this, you can track that risk score over time, and that reduces the false positives, because now when the system makes a block or allow decision, you can take a look at all the breadcrumbs or all the evidence that led up to that and see whether that was a good or a bad block. And so we'll kind of show that in a demo here real quick. So before we get into a demo, let's kind of give a quick high-level example, right? So let's give the example. It's very common these days to see password spraying and credential stuffing happening. And so this is a higher level kind of bot activity that's not going to be easily discovered just via signatures. There needs to be some type of state involved. And this actually, to be able to accurately find these types of behaviors, you need to be looking at the application, the attacker, and do some active engagement. So, for example, the application behavior might recognize that a certain entity that may be, more than one IP address is, hitting a resource with unusual intensity. And it just looks non-human because maybe they're not using the same path that a normal human uses typically for the application. So that's going to flag something on the application side. And then on the attacker behavior side, there's a combination of traits and behaviors that are going to be typical of the automation platforms. It could even be something as simple as the user agent string, or the type of URLs that they traditionally go after, right? So that could be all part of the attacker behavior that's known. And then the active engagement. So again, maybe you send in fake fields that are that would entice that particular attacker, or just automated attackers in general, that the human beings don't see, but the attackers might see. And as soon as they click on one of those things, it will also feed into that model. So all three of these things together give independent perspectives and contribute to that corroborated view of risk until you can have a high confidence that this is an automated attacker instead of a real human being. So let's take a look at this in action here. And so let me go to the screen share here. And it logged me out, so let me just go ahead and log in real quick. So we're going to log into the ThreatX UI here, just to kind of give you a view into what this looks like in practice. Okay. So I'm in the live view here, and what I'm going to do is, obviously we're tracking risk score over time, and we're looking at all those entities. I'm just going to jump into a particular entity that is exhibiting this kind of automated behavior. So I happen to know one that exists called MJ12bot, and you can see that this is an entity that we're seeing. It's got a risk level of 29 right now, and it's got a few different IP addresses associated with it at this point in time. So if I go into this entity, what I can see is that we've been tracking its behavior over a few days here. I can see those different IP addresses and different locations where they're coming from. And I can also see down here the different types of activity that it's been exhibiting. So this particular bot has been doing a lot of reconnaissance and a little bit of web application mapping as well. Typically been hitting the root, but it's also gone into the index as well. And then we've seen some responsive action, so we've temporarily blocked this entity. What normally happens is we will temporarily block an entity 3 times before putting it into a blacklist. And then, of course, I could go in and write some notes about this. If I'm in the SOC and I'm an analyst, I want to write a note saying, hey, we're tracking this particular entity because it's doing this or that. This is all stuff that you can share between your teammates. So what I want to do, though, is I want to go into this detailed view here. And this is going to kind of show all the details of what we're tracking. So first of all, I can see that there's multiple IP addresses in this bot. There could be even hundreds or thousands of IP addresses. So there's this is actually a very small one here, but it could be a lot higher than this. We're currently watching it, but I could very easily blacklist this if I want to right now. But what I want to really dive into is the actual activity. So over time, you can see the risk score for this entity has gone up and down. It's relatively stable, around 60. It's between 60 and 40, around there. These gray bars are the different match events that are happening. And I can also see, this is the area, this blue triangle is where we actually did a block action, and it went back into a watch mode after that temporary block was finished. And then on the side here, I can see different IP addresses. So we're actually correlating all this information to a single entity, even though there's multiple IP addresses. In fact, I'll go all the way down to 100 rows and kind of show you all the activities from when it started here. So what I like about this view is that it's kind of nice. It basically shows you that kill chain escalation, and it shows different areas where we're doing signature-based approach, and also when we're using some higher level analytics to see what's going on. So some of the signature-based approach here, you can see the directory traversal happening. So if I were to open this up, I can see this particular entity was doing some directory traversal, trying to get to the win.ini file there. They were doing, let's see here, some cross-site scripting was happening up here, right? So I can see, yep, there's some cross-site scripting in the query parameter. So those are kind of obvious, almost like signature-based approaches. In fact, we go beyond signatures. These are actually semantic analyzers, so that they don't just look for regular expressions, but they're actually looking to see if the cross-site scripting tags are correct and all that, or if it's a SQL injection. But I can also see that we're seeing just high-level bot stuff. The botnet user agent string was detected, right? And it looks like it's MJ12 bot. So even if this particular IP address is doing other stuff, we are consolidating it because of its user agent string as well. And so let me see if there's some more stuff that we can see that's interesting. Sometimes you'll see like a number of 404 errors and things like that over time that basically are indicators that it's crawling the site. So what's nice about this is that I can also see the behavioral rules in effect, because each one of these individual actions has its own risk score, and that aggregates up into the entity's risk score as well. So I can see at this point in time, it went from 0 to 65. So the risk score jumped up 65 points right there. And then as the bot kind of settled down, it moved down into the 30s and 40s. This yellow zone is where we start to do that IP fingerprinting and deception technology, so we can add more and more context, until finally we saw, again, more and more behaviors that increased the risk score again. We actually blocked the entity here at the entity level instead of just at the request level. So there's a lot going on here, but from an analyst point of view, this is great, because now I have all this information in a single view. I don't have to go back and correlate all this information to multiple IP addresses within my SIM. It's very easy for me to say, okay, we went into a blocked mode. That makes sense to me, because this is exhibiting, very similar to what I would expect for any type of bot. So to me, I'm not worried about this block. I'm not going to spend a lot of time with it. I'm just going to say, hey, that's fine. The WAF is doing its job here. Okay. So that's the demonstration for how we're actually taking all those different approaches of the application behavior, the entity behavior, and the interrogation and deception, and wrapping it all into a single model. All right, so go back to the slides here, and we'll just kind of talk about the takeaways here. So the idea is that the new app environments, whether they're microservices and APIs, or even traditional apps that change a lot more often, we need more modern tools and techniques to be able to cover these, because the old techniques just required too much manpower to be able to tune the signatures and keep them up to date. So the behavior analysis and attacker deception techniques provide these insights to the security team without having you to babysit every time the application changes. What we're doing is basically saying, here's all the stuff that this particular attacker's been doing, and we made an automatic decision to block this attacker, and then you can see all the reasons why. So it makes the security analyst's job a lot easier. And what we found is that when you blend all these techniques together, make sure you're not just doing application profiling, not just doing behavior profiling, not just doing deception, but by blending these things together, you can get a higher fidelity of your risk model and make higher level decisions, even when there's a complex threat that might cover multiple days of time and might even be multiple IP addresses. And so what this enables you to do is be more decisive and actually use the WAF as it was intended, to actually be an enforcement type of tool rather than just a visibility tool that requires you to do more investigation when it finds something. So in this way, you can allow it to do its job, and then and basically, if you want to verify what it's doing, it's very easy to do that without having to go in and doing a huge investigation. All right. Well, thank you. That's the presentation, and we'll be doing question and answer here. But before we get into that, just wanted to make an announcement. So we gave a super brief demo today, just kind of going into a single entity. But Thursday, April 11th, we'll have more of a full-blown demo. So if you want to kind of see more of the functionality and how this works together, we'll be sending out an invite to that. So be sure to join that for more information on how the ThreatX WAF works and how that behavior model works. So I'll open up to questions now.
Okay, great. Thanks, Kelly. All right, we'll hop right in there. And again, if you have any questions, please put them in. All right, question number 1. Is there still a use case for static signatures?
Yeah, that's a good question. So obviously there are disadvantages to signatures, but there are advantages to them. And one of the advantages is that there are certain attacks that are just very blatant, and you can get a very quick analysis as to whether that activity was good or bad. So a signature doesn't require a whole lot of higher level thinking or analysis to figure out whether it's good or bad. So in some cases, it does make sense to use signatures if there's no chance of a false positive. But the nice thing is you want to use that signature and feed that information into a higher level analytic, right? So don't just use the signature on its own, but also feed that into the rest of the system.
All right. Question 2. Do next generation models completely eliminate manual tuning?
Well, for the most part, yes. I would probably say 95% of the manual tuning goes away because we are automatically learning. There is some tuning that needs to be done for specific environments. So, for example, what I've seen before is, number one, you have a vulnerability scanner that's hitting your site. Obviously, any type of security solution is going to pick that up as a threat, but of course it's not a threat, it's just scanning for vulnerabilities, so you want to tune for those things. I've also seen things where our detailed low-level analyzers will kick off if we see SQL injection going into, say, an application like Jira, right? And maybe you have developers that are actually writing SQL code in their Jira tickets. That's not necessarily a false positive, but it's the business logic for your application. You want to allow that because it's not a threat. So that type of tuning can happen. It's very those are typically corner cases, but obviously any system has to have the ability to tune for those types of situations, and that's what we do.
Okay, all right. Another question has come in. How will behavioral analysis help deal with IoT?
Yeah, that's a good question. So, Internet of Things is interesting because a lot of times you don't want to put a WAF in front of an application that you don't really understand because it requires a lot of tuning, right? So let's say you have a camera and it has a web portal, to configure it, and it's who knows where it's developed, right? So if you were to put a signature-based WAF in front of that, there could be a lot of different, false positives that you'd have to deal with in a long tuning cycle. Whereas with a behavior-based approach, you're not necessarily concerned with every single, known CVE, known demand, but you're going to be looking for behavior that bad behavior against that IoT web interface or API. So what that really enables is more coverage, right? So instead of just covering your top tier applications, now with behavior-based technology, you can cover your, maybe your lesser known applications or your IoT devices that have web interfaces. So it is actually a great benefit to use the behavior analysis in those cases.
All right. Next, what kind of expertise is required on my team to implement behavioral analysis and deception techniques into my security strategy?
That's kind of the beauty of it. You don't have to have a lot of layer 7 expertise. Basically, that is built into the behavior models. Whereas with a signature-based approach, you have to have a lot of layer 7 expertise to even understand what the regular expressions are doing for the signatures. Whereas with a rules-based, the behavior rules are a lot more general. And the reason that they work is because a behavior rule is not necessarily a block or allow action. It's really an additive action. It's adding to the risk score. And it's just one of many different signals that kind of builds into this risk model. So the idea is that, number one, if you're managing it on your own, you don't really need a lot of expertise here. It basically will tell you what's going on in very human readable terms. But in addition to that, there are fully managed offerings that basically takes the whole WAF management off of your plate, and then basically we'll just let you know when something needs your attention and help with the mitigations of that as well.
All right. Next, what parts of the kill chain do deception techniques cover?
Oh wow, that's a good question. So the kill chain can go anywhere from reconnaissance to application mapping into brute force into exploit. And it can be applicable everywhere, but typically when you're at the higher level of the kill chain, you're just getting into blocking actions, and some of those are just really egregious signature-based type of things where it's just a known bad behavior. So you don't really even need to get to it at that point. But what's happened is before it's gotten to that point, that's when the deception and the interrogation has happened. So what we find is the interrogation and deception happens usually at the application mapping and reconnaissance stages. And because that's where a traditional app, you're going to throw that information away because it's not very valuable, and it usually tends to result in false positives. Whereas with a behavioral-based approach, you want to keep that information because it helps to build the risk model. And but you're not necessarily going to notify on that type of activity or do any blocks, but it just becomes more of the evidence in the evidence chain for that entity's behavior. So that's where it's usually done, is in the beginning, the reconnaissance and scanning.
All right. Okay, the questions keep coming in. Next one. Would ThreatX have the ability to offer a hybrid solution that could leverage both signatures as well as the behavioral analytics engine to take advantage of the positive from both categories of tools? A long one.
No, that makes total sense, though, and the answer is yes. So the idea is that the base kind of engine that ThreatX provides has some signatures, right? Like I said before, we don't just throw out the signatures. They do have some value, and they're also useful as signals into the behavior analysis engine. But the idea is that customers also have the ability to write their own signatures and behavioral rules. And those signatures can be as broad or as detailed as you'd like. In fact, you can even write regular expressions if you want to inside of each specific field, or even down to the JSON body or the XML body. So you have a lot of flexibility to do that. Typically, customers don't have to write a lot of rules. Typically, an example would be, maybe I want to block the user, any requests that come in with the user agent string of Windows 7 coming from China, right? Things like that. Those are more business logic type of things. And so you have full control, but any type of rule that our SOC can write, our customers can write as well. So there's a lot of granularity there.
All right. Next, every company claims to use AI or machine learning. What makes this situation different?
Well, yeah, that's definitely something you hear a lot. We make no claims of artificial intelligence. we don't believe what we are doing is artificial intelligence. We are using some machine learning, which is very basic. You can do cluster analysis and things like that. There's a lot of machine learning techniques that are very helpful for this type of approach. But we're basically using a combination of fuzzy logic, heuristics, machine learning, signatures, and this is all fed into that heuristics engine. And so that's really what we're doing. We're basically mimicking what a human analyst would do, but automating that. And the other kind of nice part is we're doing it in real time. So it's not after the fact, which means you can not only do the analysis, but also the active engagement with the attacker. So again, I don't want to claim that we're doing artificial intelligence, but we are using some advanced techniques beyond just signatures.
Okay. I don't believe I asked this one before, but just in case I read it, let me know. The question is, what parts of the kill chain do deception techniques cover?
Yep, so that would be the application mapping and the reconnaissance in the early stages of the kill chain.
Okay. All right. With that question answered, I think we are about done for today. So our thanks to Kelly for the presentation and to ThreatX for sponsoring this program. And of course, thanks to all of you for joining us today. This webcast will be available for viewing in a few days at www.scmagazine.com, and that can be found under the Events tab. So again, thank you all and have a great day.